Y'all good? Focus up. Okay. Get my other device. Let me log in so I can see the chat. I should have did this before. My bad. I can still see it right now. Okay. Well, that's good. Mm-hmm. All right. Awesome. Okay, cool. Cool. All right. Let's get into it. Welcome back, everybody. Watching Silicon Made Simple, a beginner-friendly tech YouTube channel where we go on Tuesdays and Thursdays and cover we break down tech topics that are hard to understand or hard to work with, and we make it more simple. And we do it as a community, and it's meant to be really for beginners, and it's meant to just be rooted in fun and a place that we can all learn together. So if you haven't been here before, the way it's structured is Tuesday we do things that are a little more related to PC hardware, assembly, and things like that. How to shop for computer parts. We've done a lot of streams on that. Um, and yeah, then Thursdays we do cybersecurity. So Thursdays are going to be more focused on cybersecurity education and labs, like actual hands-on labs. So that's what we're going to pivot into tonight. I'm going to straight up go into TryHackMe. Or actually, you know what? Before that, I want to put you guys on to some helpful pages. So what you can do, let me go ahead and share my screen so we can get started. Okay. So what you can do is actually go to Reddit. Okay. And when you're in Reddit, go to build a PC. Reddit/build a PC. Now, in this community, there's going to be a lot of people who, will ask questions about things. You can post things like whether you just want to have a discussion, you want to build upgrades, troubleshooting. There's a lot of helpful people in here that are down to, spend a little bit of time and help you guys out with anything you might need. I've been in here when troubleshooting before. Got some pretty quick answers too. So build a PC is pretty helpful. A lot of people like to come on here and answer questions just to help people out. So if you guys are not familiar with build a PC on Reddit, it's a great community that you guys can be in, and you can use this to your advantage for sure. So that's one page, right? And then also the next thing that I would recommend is actually another YouTuber's Discord. So I don't know if you guys are set up with Discord, but if you're not, I recommend getting it for certain communities. That's really what I use it for. I used to use it heavy when I was like gaming and like doing like GTA roleplay and stuff on stream. But that was quite some time ago. Anywho, PC Centric is a really cool YouTuber. He does a lot of content similar to mine. He's one of my favorites. I've actually learned a lot from him. And I think his PC building video was the first one I saw that actually made me understand PC building is a lot more simple than people think it is. And when I saw him do it, it just, he broke it down in such a way that was so easy to understand that it made me just want to go immediately buy parts and do it myself. And now you see the result of that. So yeah, I've been absolutely loving my build. It's fantastic. So you can go to PC Centric's official server. If you guys want the actual like link, I can invite you to it. So just put that in the chat or leave a comment on this video afterwards if you're watching it afterwards and you're not live, and I'll help get you in there. But it's PC Centric's official server, and you can also get to it pretty easily from any of his YouTube videos if you just go to PC Centric's YouTube channel. I can show you real quick what his channel looks like. So go to YouTube, type in PC centric, right? Boom. This guy, his name is Marcus. He's from England. And yeah, this is what his channel looks like. I'm subscribed to him. I recommend you guys subscribe too. But he's got a lot of like really cool videos that break down tech too. Um, is building a gaming PC hard. Like he put somebody who literally had no experience in tech at all building a computer, and I don't know how long it took, but they were able to do it first try. So that goes to show you that like you don't have to be the most technically inclined person to want to participate in computer assembly, which I think is fantastic because that's kind of how my thought process was at first. I was like, yo, if I can just, if I can just if I can just build one system, then I'll be geeked. And I remember when mine booted on the first time, how happy I was, bro. It was such an experience. So yeah, shout out to Marcus. Shout out to PC Centric. Go to his Discord and yeah, check out his videos. Great content overall. So now I put you guys on to some helpful resources, of course. Wouldn't be my channel if I didn't. And we're gonna jump right into TryHackMe. So in TryHackMe, I don't know if you guys don't know about this, but the way this works is they have multiple roadmaps. So like you can go to learn, and then you'll see roadmaps, paths, modules, walkthroughs, networks. There's a lot of different things you can do, right? But we are in Cybersecurity 101, pre-security path. Also, you can do, but we have started on this stream with Cybersecurity 101. So that's what we're gonna go into today, and we're gonna go into. It looks like we're in Linux fundamentals part 2. I'm not gonna lie. Now, if you guys saw the first Linux stream, it was absolutely painful. I am not good at Linux, but we're gonna power through. We learned some basic commands and how to like look at files and how to do certain things. But yeah, nothing too concrete yet, unfortunately. So if any of you guys out there are watching right now and you know Linux, please help a brother out because this is not for the faint of heart. But anyways, let's get right into it. We're doing Linux. I have to subscribe, maybe. That's fine. Because yeah. Yo, not 100. Let me get the monthly. Don't they have a monthly plan? Hold on. I might need to figure out how to do this real swift. Let me see. This is my next room, yeah. Individual plans. Yeah. Okay. So it's gonna be $17 a month for the labs. Do I think it's worth it? I think it's worth it. That's not that much for what we're actually getting. So I'm gonna pay for it so I can show you guys what it is. Any day now. Okay, cool. So now we're in here. We have access to more rooms. Do you guys want to see some more rooms, or do you want to just start Linux? Got a faster attack box. This is cool. So here's what we get with premium benefits: 15% certification discounts. Okay. We get access to all the rooms, a faster attack box, all learning paths, private servers, access to networks, so we can practice full network simulations. See, that's where I think the bang for your buck comes in. That's why I think that it's definitely worth it. Um, Money well spent, especially if you're learning. So, learning Linux part two. What are we getting into?
Hey everyone, welcome back to another video here on TryHackMe. I'm John, and today we're going to take a look at the Linux Fundamentals Part 2 room.
Do we want to do this?
Continue
Oh my
your
gosh.
learning Linux journey with Part 2.
Yeah.
You will be learning how to log into a Linux machine using SSH, how to advance your commands,
Oh, bro
and
walks you
some
through it.
file system interaction.
We're gonna figure it out ourselves. I don't want to listen. We're gonna just get into it, bro. Let's proceed. All right, we're in here. I like the satisfying green click. That's the only reason I did it like that. Okay, so the in-browser functionality was used in the Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. The browser functionality uses the same protocol that we're going to use today. This protocol is known as Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. This is also on your CompTIA A plus study. So those of you who are studying for that exam, make sure you know SSH, the secure shell, and what port number it is. We will be deploying two machines in this room, the Linux machine and the TryHackMe attack box. So let's learn a little bit about secure shell and what it is. Secure shell, or SSH, is simply a protocol between devices in an encrypted form. Using cryptography, any input that we send in a human readable format is then encrypted for traveling over a network, where it is then unencrypted once it reaches that remote machine, such as the diagram below. So your computer sends information to the internet, and then it goes to the Linux server. While it's in the internet slash the clouds, it's encrypted, right? So if anybody were to take it from the cloud server before it got to you, this is what they would read. Mumbo jumbo. It doesn't mean anything. But once it is verified and on the receiving end gets read by the Linux server, it will transcribe the original message that was sent from the original computer. That's kind of how encryption works. It's like protecting something while it's in transit. So, excuse me. We can learn about the various types of encryption on a TryHackMe room. For now, all we need to understand so we don't overwhelm ourselves is Secure Shell allows us to remotely execute commands on another device. Okay? Remotely. So you don't need to be there. Any data that's sent between the devices is encrypted, and when it's sent over a network, such as the internet. Make sense? Cool. So, deploying your Linux machine, all you have to do when you're on TryHackMe, you don't have to have a virtual machine. That's why I like this. So for you guys who might have a laptop or you have limited RAM resources where you can't allocate a full 4 GB of RAM to a virtual machine to get it to function the way you want, and if you have no clue what I just said, go back and watch some of our previous broadcasts. We go over virtual machines, what they are, how they work. I even give you guys a little bit of information about how to install them. So definitely watch that. But a virtual machine is literally a virtual operating system that you can use inside a computer. So what do I mean by that? You can create a virtual machine and then operate Windows 10 on top of your Windows 11 operating software. So it's like a fake version of that computer on your computer. Makes sense? Now, what do we care about virtual machines for? Sandbox environments for practicing coding that actually does stuff. Um, it gives you like a house to practice in for a lot of things. And virtual machines are also used for deployment of certain infrastructure in different scenarios. So, yeah. With all that being said, you don't need a VM for this. It's all browser based. So you just need an internet and you're good to go. You can click start machine. Okay. Starting your machine. Please wait. Thank you. All right. Then scroll to the top of the page to see the deployment information. What's going on? Where is my machine? Target machine. Oh, there it is. Target machine info. Okay, yeah. So got it. Scroll to the top of the page to see the deployment information. The IP address that's displayed that you will be logging in for Secure Shell. Got it. Okay. So that's our IP address that we're going to use to log into the Secure Shell server, or port, I should say. I don't know what's the correct terminology for that, to be 100 with you. But there we go. We have our target IP address. We just copied it. Okay. It expires in 2 hours. So that IP address was only leased to 2 hours. We can add time to it if we need to. What does this do? Let's see. We can start the attack box or you use a VPN. Well, we'll get into VPNs. I want to do an actual like stream about VPNs and how to use them and stuff. So for now, let's just stick on. Let's just stick to the path. Using Secure Shell to log into your Linux machine. All right, let's do it. Okay, so I have started my attack box. Okay, we're just gonna wait for that to warm up. Okay. Okay. So we have our IP address. We've taken note. Looking at the top of the page, start the attack box. We just did that. The syntax to use SSH is very simple. We only need two things: the IP address of the remote machine and the correct credentials to a valid login on that remote machine. For this room, we'll be logging in as TryHackMe, and the password is TryHackMe. No quotation marks. To use the IP address of the machine displayed on the card at the top of the room as the IP address and this user. To construct a command to log into the remote machine using Secure Shell. The command to do that is SSH and then the username of the account, the IP address of the machine. And then you got the IP address of the machine. Okay. But first, we need to open up a terminal on the TryHackMe attack box. There's an icon placed at the deck bar on the desktop named terminal. Okay, so I guess we'll just wait a second for our machine to initialize. This is like a virtual machine, remember? So, okay. What's going on here? Okay. So it's gonna give you some stuff like that. This is a Linux machine, by the way, guys. Remember? Okay. So we're gonna open our terminal. This is our root IP address. Okay, so that's the terminal. We opened the terminal on the TryHackMe attack box. That's what we did. And now we can proceed to input the commands. So let's input these commands. So let's do SSH, which is secure shell, SSH, right? The command to do is SSH and then the username of the account. So SSH, TryHackMe, And then the username of the account, and then the @ of the IP address of the machine. So no spaces, SSH, TryHackMe at, what's our target IP address? This. Oh, I don't know how to copy and paste in Linux. Does anybody know how to paste in Linux? Like the keyboard shortcut? That'd be far. All right, well, let's just type it in 10.145.187.174. I was typing nothing the whole time. Fantastic. 10.145.187 on an undercover account. .174. The authenticity host can't be established. Why? Oh, that's what it said. Are you sure you want to continue connecting? Uh-huh. Wait. What's going on here? But first, oh no, we did that. Once executed, you will be asked to trust the host and then provide a password. Yes. What's the password? Me password is Trizzle Hack Mizzle. Why is it not letting me type it in? Oh, okay. I don't know why it's not letting me. Hmm. Wait. Wait a second. Wait, I don't think I did it right. You will not be able to see any text or symbol. It is still working. Just type and press enter to log in. Okay, well, I guess I did that. Oh, so now I'm in, right? No, I'm not in. Okay, let's try it again. Dot 187 dot 174. I'm in there. Okay, so that's how you had to do it. Just do it step by step, like because the password was the same thing, and that's what was confusing me was that when you're typing the password, you don't see anything, so you're kind of just make sure that you're typing very carefully. But now we are logged into an Ubuntu version of Linux, and we are okay to continue. All right, cool, cool. Majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of commands. Using our ls example informs us that there's only one folder named folder 1 as highlighted below. Okay, so ls, ls. What's in there? However, after using a negative A argument short for all, okay, now we suddenly have an output file. So if I type negative A, what? Um, ls, ls. If you files that are hidden files, commands that accept these will also have help options. Okay. All right. Okay. All right. Wait, I didn't mean to capitalize it. Man, ls. Oh, that brings me to this. Let me expand this a little more. It's kind of hard to see. I don't need to see the whole like desktop of the virtual machine. I'm really just working with the terminal. So negative eight. Okay, cool. Yeah, I just opened up this thing. So I'm not good at all with Linux. I like just started learning it and like trying to understand it in its entirety. So I'm really just going through TryHackMe right now and just trying to get a better understanding of it. But there's this video too that I can use. So let me kind of get to where I'm at here and light it up, and then that way I won't waste too much time.
86. And then we'll type in yes. And then our password for that user is.
So we did that.
When using a command, unless otherwise
you guys
specified,
can do this too, man.
it will
It's
perform its default behavior.
It's on
For example,
TryHackMe.
ls lists the contents of the working.
I don't know if you can get this far. I just paid for it, but it was like $17. But yeah, TryHackMe is a great platform. So that's what I'm doing to.
However,
learn
hidden
Linux.
files are not shown. We can use flags and switches to extend the behavior of commands. Using our ls example, ls informs us that there is only one folder named folder 1 as highlighted in the screenshot below. Note that the contents in the screenshot below are only examples and are not those of the instance you deploy in the room. So this is just an example. It won't be the case over here.
Okay.
However, after using the -a or -a argument, short for --all, we now suddenly have an output with a few more files and folders such as .hidden folder, And then we can see a couple other ones here. Files and folders with a period at the beginning are hidden files.
Okay.
A lot of times this is just system things or more configuration files that you don't necessarily need to see otherwise, and that's why these are hidden by default.
Okay.
Commands that accept these will also have a -- help option. Sometimes this is -h, however, not every command has a -h that specifies help. However, most commands that we can use have this -- help option.
Okay.
This option will list the possible options that the command accepts, provide a brief description, and an example of how to use it. This option is, in fact, a formatted output of what is called the man page, short for manual, which contains documentation for Linux commands and
So, I don't know if you're still here, Tara, but what is -a? What does it actually do?
applications. The manual page, the manual page or pages are a great source of information for both system commands and applications available on both a Linux machine,
Oh, okay.
which is accessible on the machine itself, and online. So here we can see that we have the online version of the man page. You can click into that and explore around. It can be very helpful for searching if you're not that comfortable with the command line yet. And this will also come up in Google results along with Stack Overflow. Both of those are a pretty good resource. To access this documentation, we can use the man command and then provide the command we want to read the documentation for. Using our ls example, we would use man space ls to view the manual pages for ls like so. And we can see an example up here. Explore the manual page of the ls command. Let's go ahead and do man ls.
Wait, why did I just... Oh, I muted him on accident.
Be used to navigate down the
Dang it.
both system commands and applications available on both a Linux machine, which is accessible on the machine itself, and online. So here we can see that we have the online version of the man page. You can click into that and explore around. It can be very helpful for searching if you're not that comfortable with the command line yet. And this will also come up in Google results along with Stack Overflow. Both of those are a pretty good resource.
Oh, so these aren't separate things.
To access this documentation,
this is what you type in man command.
And then provide the command we want to read the documentation for. Using our ls example, we would use man space ls to view the manual pages for ls like so. And we can see an example up here. Explore the manual page of the ls command. Let's go ahead and do man ls.
Okay, so we're in
here. There we go. Mark that as complete. And then what directional key will be used to...
All right, so let's go mark that as complete. All you do is click check to mark it complete. It's like answering it basically. So what directional arrow key would we use to navigate down the manual page? Is that a trick question?
To navigate down the manual page, that is going to be the down arrow.
Okay, bro. It can't be that complicated where it's like you don't press down to go down, dude. I would have tripped. I would have rage quit right now. Okay. Bruh. What flag would we use to display the output in a human readable way? What is the flag again? Huh. Oh, I'm sorry. I gotta close my Discord, bro. That's what that sound is. That was getting annoying. My apologies. What flag would we use to display the info in a human readable way? Let's continue.
Fairly self-explanatory. And then what flag will be used to display the output in a human readable format? Now we can scroll down and eventually we will find a -h command or dash H flag, rather, that allows us to specify that we want our output from ls to be in human readable format.
Whoa, right here.
And there we go.
There it is.
Let's move into task 4.
So dash H is going to make it human readable. Starts with 1 or 2 dashes. Okay. So that's the name of the 1 or 2 dash entry. Got you. You're a legend. Thank you. Dash H. Do you use Linux every day? Like, do you have a system with it? Or I would love to know. Because it seems, I'm not going to lie, it seems daunting. But yeah, everything new is uncomfortable at first, I guess, right? Okay, cool.
File system interaction continued. Now we can go ahead and close the man page by pressing Q, and we can see that's down here as well. There we go. We covered some of the most fundamental commands when interacting with the file.
All right, so let's go ahead and close this, and then we will continue following along. So it looks like I can close this tab up and open up task 4. So we're on task 4 now, and let's go.
File system on the Linux machine. For example, we covered how to list and find the contents of folders using ls and find, and navigating the file system using cd.
Oh, quick question, Tara. Do you use what Linux distribution do you use? Are you on like Ubuntu or like Kali or like, I don't know that many, but I know there's a couple different ones. And also, I'm like interviewing right now, but if you wouldn't mind telling me why you like it too, that would be cool because I'm interested in learning a lot about what we're doing here. Nixos, Nixos, Nixos. What is that, and why'd you choose that one?
In this task, we're going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders.
Okay, so now it looks like we're working with file management. Covered some of the most fundamental management. Yeah. So we're going to learn some commands for interacting with the system so that we can make files, move files, and delete files. See, like, this is why I struggle to understand why anybody would want to use Linux, because like we have to type in like codes to do this, and it's like you could literally just like go on your desktop and like click and then click new and then like create a file. It's like a couple clicks on a Windows system, as opposed to like, why do we have to like memorize commands? Like, I don't know, man. I love it, but I hate it at the same time. All right, let's keep moving.
And you can see that you have the list here. I recommend adding that to your notes. And then we have a pro tip at the bottom.
Okay.
Similarly to using cat, we can provide full file paths, i.e. directory 1, directory 2, note for all these commands. So you can provide full paths for these as well as relative paths, which don't worry about that too much right now. This is just the full proper path to it on the system.
If we need more time, we can extend it too.
Creating files and folders with touch and make dir. Creating files and folders on Linux is a simple process. First, we'll cover creating a file. The touch command takes exactly one argument, the name we want to give the file we create. For example, we can create the file note by using touch and then space note. Again, where note is the name of the file.
Is that what it's called when you type in a command? It's called an argument. The touch command takes exactly one argument. I don't think I confidently understand the difference between flags and arguments. Yeah, no, okay. I know about that. I know about that command. And yeah, I actually learned about that in one of the CompTIA classes I was taking. But yeah, I'm not. I know that. I know that sudo is like. Yeah, no, I know. It's bad. I don't know what it does, but I remember it's a bad. But thank you very much for the warning.
It's worth noting that touch simply creates a blank file. You wouldn't need to use commands like echo or text editors, or you would need to rather use commands like echo or text editors such as nano to content to the blank file. And here we can see that down here after that has been created with touch.
Okay.
This is a similar process for making a folder, which just involves using the makedir command or mkdir command and providing the name that we want to assign that directory. For example, creating the directory my directory, we can do that with makedir and then the name of the directory right here,
So make
my
directory,
directory. And we can see that's done in the example below. Removing files and folders with RM. RM, short for remove.
I guess it is pretty simple. I was kind of talking early. Any text other than a flag. Okay. So an argument is like the body text, and then the flag is like the pretext. But the flag also is like what you type in for the command. Am I kind of on the right track?
Is extraordinary edit commands that we've covered so far. You can simply remove files by using RM. However, you need to provide the -R switch alongside the name of the directory you wish to remove in case you want to remove a directory. So this is a recursive option, I believe, which removes the directory and all of its contents. Is otherwise RM will say, hold on, I can't do this. So here we can see that we've removed note in this example, and that file is no longer here. However, to remove a directory, you can see it doesn't work without providing -R, but if we provide -R as a switch, it will remove it.
Oh, okay.
Copying and moving files and folders with CP and MV. Copying and moving files is an important functionality on a Linux machine. Starting with CP, short for copy, this command takes two arguments: the name of the existing file and the name we wish to assign to the new file when copying.
Okay.
CP copies the entire.
Okay, yeah. Now I understand what you now like what you explained, Tara, and what he just said. Now I get it. I get what the argument is.
Contents of the existing file into the new file. In the screenshot below, we are copying note to note 2. And we can see that right here.
Last time I did Linux,
moving a file takes two arguments, just like the CP command. However, rather than copying and or creating a new file, MV, short for move, will merge or modify the second file that we provided as an argument. Not only can you use MV to move a file to a new folder, but you can also use MV to rename a file or folder. And you can just move it to the same location that it's already in if you want to just rename it. For example, in the screenshot below, we are renaming the file note2 to be named note3, and we can see that right here. Note3 will now have the contents of note2 because it was that file at one point. Determining file type. What is often misleading and often catches people out is making presumptions from files as to what their purpose or contents may be. This is something that's very common in CTFs. And this next command, especially for CTFs and in a situation where you don't have a file extension, is going to be very handy in those cases. Files usually have what's known as an extension to make this easier.
Okay.
For example, text files usually have an extension of .txt, but this is not necessary.
Yeah.
Windows will require this for most files, and that's how it knows what program to open it with by default, and I believe OS X has a similar functionality with it. However, Linux doesn't really care. We don't have to have file extensions. It's recommended, as it is best practice. However, it's not necessary. So far, the files we have used in our examples haven't had an extension. Without knowing the context of why the file is there, we don't really know its purpose. Enter the file command. This command takes one argument. For example, we'll use file to confirm whether or not the note file in our examples is indeed a text file, like so. And you can see that we've done that with file and then the file that we want to examine. And sure enough, it is an ASCII text file. How would you create the file named new note? We can do that with the command touch and then the name of the file we want to create.
Okay. So in order to create the file named new note, there's going to be the command touch and then the argument new note. Right. Okay. So command and argument. Right?
On the deployable machine, what is the file type of unknown
Right.
one in TryHackMe's home directory? So we can do ls, and we have unknown one. We'll do file unknown, and I can type part of that
Wait. I missed that. Let me go back just a tad.
with the command touch, and then the name of the file we want to create.
Okay.
On the
deployable
deployable machine, what is the file type of unknown one in TryHackMe's home directory?
What is the file type of unknown one in TryHackMe's home directory? So there's a file called unknown one in the directory, and we want to know what type it is. How are we going to do that?
We can do ls, and
We can do ls. Big ls. You know what's going on. All right.
we have unknown one. We'll do file unknown.
Oh, mama. File unknown. Wait, so in this case is the word file a flag? Unknown one. Oh, it's ASCII text. What is that?
And I can type part of that and hit tab to have it autocomplete. And there we go. We can see that it is an ASCII text file.
ASCII text file. ASCII text file. What is an ASCII text file? File is a command. Okay. ASCII text. Excellent. How would we move the my file to the directory my folder? Move. It would be MV. How would we move my file to my folder? MV, my file, my folder? Let's see if I'm right.
There we go. How will we move the file, my file, into the directory my folder? We can do that with the MV command, and then my file, and then my folder.
Yeah, buddy. Look at me Linuxing, dog. Cool.
And there we go. What are the contents of this file? So let's see. We want to cat my file.
What?
Cat my file. There we
You
go.
mistyped it. I almost copied, bruh. THM file system in brackets. In squiggly brackets. And it's in all caps. So I should probably put it in all caps. THM, squiggly brackets, file system. Boom shakalaka. Continue to apply your knowledge and practice the Linux commands from this task. I think we used them all. We didn't really copy anything. I kind of want to remove this for fun. But I don't. Let me chill.
And there we go.
You just let your intrusive thoughts win. Oh, thank you so much. So you said ASCII text files are just the most basic form of text file. So like letters and some symbols, but not emojis. Oh, okay. So bare bones. Okay, gotcha.
Apply your knowledge and practice the commands from this task. I do recommend playing around just a little bit so that
Yeah.
you can become a little bit more familiar with these commands. Once you're ready, go ahead and move on to task 5, permissions 101.
All right, let's go to task 5. Cool. All right, now we're on task 5, permissions 101. We're moving and grooving here, baby. As you would have already found out by now, certain users cannot access certain files or folders. Let's keep filing. Let's keep following along. I feel like it was smoother when we follow along with the video.
As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads. In our previous task, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using the tac L or -L switch, we can see 10 columns such as in the screenshot below. However, we're only interested in the first 3 columns.
What'd you say, brother? UTF-8 is a text format for more advanced stuff. Right? Did I read that right? Is that -8? Yeah. For more advanced stuff. Oh, so you could put like emojis or like GIF files or something in there? Like, I don't know.
And you can see that right here where we have the properties and D right here. It's a little bit covered up by the outline that specifies where there's a directory, and a dash in that first bit here specifies where there's a file. Okay. Then we have the file owner, and then we have the group that's an owner. One thing to note on Linux, whenever you create a new user, there is a group that's created that's named the same as that user. Hence why we have a user CMNATIC, and then we have a group CMNATIC. Although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder.
Okay, so I did learn a little bit about these read and write and execute commands because of the CompTIA Core 1202 studies, like the second part of it. They do teach you a little bit about this, so I'm a little bit more familiar with what these means: read, write, and things like that. I remember this a little bit.
And whether or not we have access to it.
A
file or folder can have a couple of characteristics that determine both what it is,
hope you have a great night,
what it is that, and who can do with it as. So in other words, it determines the owner and what we can actually do with it. If we can read, write, or execute the file. We can see that broken out down here below. The diagram below is a great representation of how these permissions can be translated. And we can see that we have these 4 different areas that we're looking at. And again, that's mirrored up here. So breaking this down, again, I mentioned this previously that this first bit here specifies if it is a directory or just a regular file. Since we have a dash here, we know we're working with a file.
Still got time on our terminal.
Next, we have RWX. This is short for read, write, and execute. This first group here is the permissions that are available for the file's owner. Next, we have those in the same group as the file owner. And last but not least, everyone else on the system.
Execute.
And we can see that in this case, since RWX is available or printed at each one in every single space here, everyone can read, write, and execute this file in question.
Makes sense.
However, in this case, if we scroll up just a little bit more, we can see that there are examples where there are dashes instead of those letters. Where there is a dash, that permission is not available for those in that user group. So if we take a look at this example right here, we have that the user who owns this can read and write to it, but not execute it, and everyone else can only read it. There's no write or execute set to be available. Let's use the cmnatic.pem file in our initial screenshot at the top of this task. And you can walk through this as well. So here we can see that we have the cmnatic.pem where the owner can read and write to this file, but no one else can do anything. And the owner cannot execute that. Briefly, the differences between users and groups. We briefly explored this in Linux Fundamentals Part 1, namely the differences between a regular user and a system user. The great thing about Linux is that file permissions, or permissions rather, can be very, very granular that whilst a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner
Oh,
itself.
so this is kind of like how you would manage your system, and like allow or deny permissions, kind of like
Let's put this
how you would
into
like
a
password
real
protect
world
files and
context.
stuff.
The system user that runs
That's
a
like
web
what
server
I'm
must have
relating
permissions
it to,
to read and write files for an effective web application. However, companies such as web hosting companies
which I don't
will
know if that's
have
entirely
will
correct.
have to want to allow their customers to upload their files for their website without being the web server system user, compromising the security of every other user. So essentially,
So again, real quick, Linux Fundamentals Part 2 on TryHackMe is a premium room. You do have to pay for it. If you do monthly, it's $17. If you do the yearly plan, it's a little bit cheaper. It comes out to like $10 and some change, around 100 total for the year. So whatever you want to do. I definitely recommend it though. But if you guys don't have it, just hang out with us and watch it through my channel.
when you are interacting with a web system or a website rather, such as TryHackMe, and you can upload something like a profile picture, you are running that actual process is running as a low privilege user that can't just overwrite files on the website. That wouldn't be very secure because then we could upload whatever website we want on anyone's website. And that does happen. That is a common security issue. Okay, uncommon security issue, but it does happen. Switching between users. Switching between users on a Linux install is easy works thanks to the su command, short for substitute user.
Okay.
I like to remember this as switch user. It's not technically correct. Substitute user is the way that this is abbreviated from. Unless you are
I
the
like
root
Switch
user
user
or
also.
using root permissions through sudo, then you are required to know two things to facilitate this transition of user accounts:
I'm like working
the user we
overtime
wish to
tonight, dude.
switch
I gotta
to, and
design
then
that
that
ring
user's
after this.
password. You need to know that user's password in order to
I'm
change
not gonna
to
stay
be them,
online for that though. It's a private
unless you
client.
are
I'm
just
sorry,
super
guys.
user. The su command takes a couple of switches that may be of relevance to you. For example, executing a command once you log in or specifying a specific shell to use. You might have a specific shell you really want to use, such as Bash or ZSH. That's up to you, and that's outside of
Okay.
the scope of this actual room. Don't worry too much about this, just something to have as a general piece of knowledge. I encourage you to read the man page for SU to find out more. However, I will cover the -L or dash login
I
switch.
think my sister is much better at
Simply by
Linux, and I'm
providing the
excited because she's gonna
-L
be here
switch
next weekend.
to SU, we start a shell that is much more similar to the actual user logging into the system. So it simulates an actual login. The thing with this is we have that user's environment variables actually populate, which can be
Oh,
very useful,
okay.
especially if we are in a programming environment where we need to have access to, say, for example, we're assuming the web user that runs the website. We want to be able to access that user's environment variables, and we want them actually loaded into our current session. So makes a big difference. If you have a development background, that will make a little bit more sense. For now, don't worry too much about it. Just if something's not working, you probably need to use this -L switch.
Okay.
For example, when using SU to switch to user 2, our new session drops us into our previous user's home directory. So we can see that using the login here, it is moving us to that home directory because we're
Remember,
actually
read, write,
simulating that
execute.
login and we're switching what directory we're in.
Read, write,
We're
execute.
now, after using the -L, our new session has dropped us into the home directory of user automatically. And you can see if we don't use it, we just stay in our old home directory where we don't have permissions for anything.
Yep.
Not very convenient. On the deployable machine, who is the owner of important? So we can go ahead and do ls-l.
Okay, so on our virtual machines, let's do ls-l. I don't think it needs to. I don't know if capitals matters. Is Linux case sensitive? Does anybody know?
And we can see that important is owned by user 2. There we go. What would the command?
Oh, so important, which is this folder. So it brings it up. Important is owned by this user. Okay. So we typed it in and it's telling us user 2 owns the important file. Usar 2. What would the command be to switch to the user 2?
Command B to switch to user 2. We saw that below before in our examples with SU and then
Switch
user 2.
user. Okay, user 2. So the command is switch user and then user 2. SU user 2. Oh, no, I don't want to do that. It's just asking me. I don't think I'm supposed to do it yet. SU user 2. Now switch to this user 2 using the password user 2. Eh?
Now switch to this user 2 using the password user 2. We can use SU, and then I'm going to use the -L to switch to that user's home directory.
Okay. Switch user -L. What's the password?
Actually, we don't want that in this case. SU user 2, and then user 2.
Uh-oh. Wrong one. SU.
And then we want to be able to.
Uh-oh. Uh-oh. Wait. Wait, what? Bruv, what's going on, bruv? What's going on, bruv? Do I need to reset it? Reset my terminal? Did that help? Oh, no, I forgot. I'm typing in the password already. Okay. This is Susu. Switch to user 2. I've done it. I'll pocket it all up for a second.
read important. Let's go ahead and cat.
Wait, he lost me. 2518.
Now switch to this user 2 using the password user 2. We can use SU, and then I'm going to use the -L to switch to that user's home directory. Actually, we don't want that in this case. SU user 2, and then user 2. And then we want to be able to read important. Let's go ahead and cat important. And there we go. Now, one thing to note, we could read this beforehand because the root permissions are enabled. However, we're reading this as the actual user now. And there we go. We have our flag, THM, SU underscore user.
Boom.
User 2. And there we go. Let's move into task 6, common directories.
All right, we're grooving.
First, we have
Almost done,
/etc
actually.
or etc. This root directory is one of the most common or most
I don't know,
important root
7 out of
directories
10.
on your
I
system.
don't like Linux.
The etc
Keep it a
folder,
band.
short for etc., and etc is the common way to pronounce this. It's pretty fast, and it's just commonplace within IT to
Etsy?
call
Yeah.
it that way or pronounce it that way. Is a commonplace location to store
like
system
Tech Bro
files that are
pronunciation.
used by your operating system.
I would have said it.
For example, the sudoers
several.
file, which allows that specifies who can run things with root permissions. Don't worry about this too much. It's outside of the scope of this room. Just know that it exists and something you'll eventually want to be familiar with. For example,
Okay.
the sudoers file highlighted in the screenshot below, which we can see right here, contains a list of the users and groups that have permission to run sudo or a set of commands as the root user. Also highlighted below are the passwd and shadow files. So we can see those right here. Those two files are special for Linux as they show how your system stores the passwords for each user in encrypted formatting called SHA-512. Don't worry too much about this. These are very powerful files. If you are in a system you don't own and you have root permissions, or if you can somehow access especially the shadow file right there, you can do very bad things. Don't worry about it too much right now. Just know that these files should be protected. You can read this passwd as any user, but you should not be able to read shadow. /var.
Shadow file. Sounds like something I want to learn more about.
The /var directory, with var being short for variable data, is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here. So, for example, specifically in the var log file, or in that directory rather, or other data that is not necessarily associated with a specific user. For example, databases in the like.
Okay.
Then we have /root. Unlike the /home directory, the root folder is actually the home for the root system user. This is just their home directory. And again, I preface this a little bit in Linux Fundamentals Part 1. This is just where your document that your user specifically owns will live. Pictures, your desktop, things like that.
The desktop.
There isn't anything more to this folder other than just understanding that this is the home directory for the root user. But it is worth a mention, as the logical presumption is that this user would have their data in the directory, in a directory such as home/root, which is not the case. Root does have its own directory, and this is consistent off of, I believe, every single Linux distribution.
Yeah.
There may be some bizarre Linux distribution that doesn't have this as a default rule. However, I've never come across it. /temp, or TMP. This is a unique root directory found on a Linux install, short for temporary. The temp directory is volatile and is used to store data that is only needed to be accessed once or twice. Now, one thing to note, don't put anything here you care about, especially don't take notes into this directory. It's something that as soon as the computer is restarted, which is referenced right here, this is cleaned out and everything in there is just wiped.
Oh.
I've made the mistake of storing things in this folder that I cared about. Don't make the same mistake. Don't store anything in there that you don't need very temporarily.
Oh, okay.
What's useful for us in pen testing is that any user can write to this folder by default, meaning once we have access to a machine, it serves as a great place to store things like our enumeration scripts. You can store your shell here. Sometimes this won't be the case, but again, that's outside of the scope of the room.
Remember, pen testing is short for penetration testing, which is part of red team cybersecurity. Remember we talked about red versus blue team? Penetration testing is hired cybersecurity experts who will try to get into a system and then let you know how they exploited it, what kind of vulnerabilities they were able to get in through. Yeah, it seems like a really, really fun job. It's in high competition in the field. So yeah, that's what they mean by pen testing. They mean penetration testing. I think it's also kind of known as ethical hacking. So ethical hacking, penetration testing, same ballpark. Definitely something you can learn about on like Udemy. They have some ethical hacking courses. And then on this channel, we're going to get into penetration testing heavy. So don't even worry about that. But yeah, let's continue.
Generally speaking, /temp is going to be your friend just to check things into, is you can by default write to it. README, we've gone ahead and completed that. What is the directory path that we would expect logs to be stored in? That is var log.
Okay. I don't know if it's case sensitive, but what root directory is similar to how RAM on a computer works? You know what? I was actually thinking about that while he was saying it, and it's kind of like temporary, right? So the TMP command, as soon as you shut off your system, is going to wipe out the file or whatever's in there. That's kind of how RAM works. Remember, I told you your SSD and your RAM are both storage, but the RAM is operating storage and the SSD is stored storage, like your locker, your vault. So I'm going to go ahead and say that based off of how I understand PC assembly, it would be TMP. And I was correct. So we didn't even need Homeboy to answer that one for us.
What root directory is similar to how RAM on a computer works? This is cleared on restart, and then that's the /temp directory. Name the home directory of the root user, and that is going to be slash
Home
root.
directory of the root user. Yeah, root. Home directory, desktop kind of thing. Root. Cool. Done there. Conclusions and summaries. All right, nice work. This room was quite theory heavy, and we covered a range of fundamentals in getting us familiar with Linux. To quickly recap, what did this room teach us? How to connect a Linux machine remotely using Secure Shell. That was pretty cool. Advancing your use of commands by providing flags, switches, and where you can go to learn about each of these commands. Again, shout out to Tara for helping us learn the difference in the chat. And we had some more commands that you'll frequently be using to interact with file systems and its contents. So, how to open them, how to read them, stuff like that. A brief introduction to file permissions and switching users, and then a paragraph of the important root directories on an Ubuntu Linux install and how we may be able to use data stored within these. So again, Ubuntu Linux is the distribution. So Linux is the system or the operating software, and then the distribution package slash what it's capable of and how it really works is Ubuntu. In that example, of course, like Tara told us they operate with Nixos, Nixos. So yeah, it's a distribution. I encourage you to go through this room once or twice and get a little more familiar. Yeah, for sure, Doug. I'm gonna do that off stream because I don't want to take up too much of your time. We're about to be finished. Terminate the machine from task 2. Oh yeah, we gotta terminate the machine, man. We're done. We don't need this no more. Connection has been closed by the remote host. We can close the terminal and we can turn off our virtual machine. And done. Join Linux Fundamentals Part 3. We're done, man. So, cool. Okay, sure, man. Leave me alone. Okay, I got another Cat Linux badge. All right, I'll share that on my LinkedIn. Anywho, that's it, man. We learned about PC centric. We learned about Linux. The next room is going to be Linux Part 3, and then I think that's really going to complete. Where are we at in the path? Let's do a little review real quick. So we're on Cybersecurity 101, and we are in Linux Fundamentals Part 3. After that, we move on to Windows. Now, I'm going to keep it real with you guys. If you don't know Windows, it's super simple, and I'm really good with Windows. So we'll probably like breeze through this. And command lines, I'm pretty good with. Also, I understand like, how to test networks using ping and stuff like that. Windows PowerShell, Linux shells, not too familiar with. And then we go into networking, which is going to be really cool. Secure protocols, Wireshark. There's a lot, man. We're really gonna grind this certificate out. Again, these certificates just show that you commit to learning, and I think that that's valuable, and I think that they're cool for your LinkedIn. And I think that they're a good thing to just go ahead and spend your time doing, bro. Play less video games, learn more computer shit. Let's keep it real. But yeah, thank you guys so much for rocking with us. This has been Silicon Made Simple, where we take some harder to understand computer tasks and concepts and we break them down and try to make them more fun and more community based. And we all just learn together here for real. So if you guys stuck around to the end, thank you so much. I think I'm going to create some social media pages soon. I should probably have done that already, but yeah, there's going to be a Discord coming and some socials. Like I'll probably be posting some of my YouTube shorts and stuff also on maybe a TikTok page. But yeah, let me know if you guys have any recommendations for the community. If there's anything you guys would like to do to contribute, I'm all ears, and I can be found here right on YouTube. Just leave a comment on this video and I'll get back to you as soon as possible. The next time I will see you guys is going to be Tuesday. And I think we're going to go ahead and move into laptops. I'm going to teach you guys about the infrastructure of how laptops work inside because they're a little bit different. Keep in mind, your peripherals on a laptop are all in one machine. So your mouse, your keyboard, your screen is part of the system. So the wiring is all different, and it's a little bit of a different ballpark. But I'm excited to dive into that with you guys. I fixed multiple laptops too. It's actually, to me, I started playing around with laptops because they more closely resembled like video game systems. And like I used to fix the red ring of death on my Xbox for friends and stuff. I know if you guys remember that, that was a crazy time in gaming. But yeah, before I go on another rant, that's what it is, baby. Thank you guys for rocking with us, and I will see you Tuesday for laptops. Stay safe this weekend. Have a great one.